Scientists say there's a place in our solar system outside of Earth that has the chemical makeup to potentially support life. That place is Enceladus.
For years, astronomers have been drawn to Saturn because of what bubbles up from an ocean hidden by a layer of ice. There's a fresh twist in the tale now. Researchers analyzing data from NASA's Cassini probe have spotted mysterious objects almost 2,000 miles long smashing through Saturn's clouds, leaving sparkling trails behind them. This discovery caught scientists off guard. Scientists are perplexed by the bizarre flying saucer-shaped object's creation. This incredible find on Saturn's moon has infused a renewed zeal into the search for alien life within our solar system. What is this thing with a saucer shape? Could there be intelligent life beyond Earth on Saturn? Join us as we investigate the UFO sighting near Saturn that's sending tremors across our understanding of the solar system. A NASA spacecraft has just obtained its most stunning view yet of a small flying saucer that is orbiting well within Saturn's rings. The new images initially made Cassini scientist Carolyn Porco believe they might be works of art. They are genuine. Science has an advantage over fiction. On March 7th, NASA's Cassini probe captured the unusual shape of the saucer, which turned out to be a small moon called Pan. Pan, after the Greek deity of wild places who played the flute, is a shepherd moon with a diameter of 21 miles. It occupies...
And to me, that doesn't mean anything. Because I'm a person that's still of the thought that Oumuamua, which we think is possibly a rock or space debris or whatever you want to classify it as, I'm the person that still thinks that's a well-disguised spacecraft. I'm him that thinks that. So when you tell me, oh, that's just the moon, so that still is not wavering me off of what I think that is.
Occupies a hole in Saturn's A ring, the outermost ring of ice particles. Pan, like a miniature Roomba armed with a force field, continuously clears debris from the gap as it whizzes around Saturn. It was the lack of ring debris that first tipped off astronomers to the existence of Pan in the mid-1980s. It wasn't until 1990, when scientists led by Mark Showalter carefully examined data sent back by NASA's Voyager 2 mission, that they confirmed the presence of the tiny moon responsible for creating the gap. The Cassini spacecraft's rapid transit through Saturn's system has finally afforded astronomers a close-up view of Pan. Its distinctive walnut shape was initially attributed by Porco and her colleagues to ring debris seen in early photographs. Newer photographs reveal in great detail that the moon is wrapped with an equatorial accretion disk, a thin, smooth covering of ring particles stuck to Pan's waistline by the moon's weak gravity. This is such a far cry from the nondescript dots that I was tracking way back in 1990 in the Voyager images. It's very gratifying finally to see Pan's close-up, says Showalter, now at the SETI Institute in California. In a 2007 study published in Science, Porco suggested the thin disk formed long ago, before the moon had completely vacuumed out material from the gap. The shape, as others have also pointed out, is probably because it is always sweeping up fine dust from the rings, Showalter explains. Due to Pan's large size and relatively thin rings, dust is concentrated near its equator. Pan isn't alone in its bizarre appearance. Another small moon, Atlas, bears a similar shape for similar reasons. On the frigid moon of Saturn, however, researchers have revealed yet another astounding finding. Scientists discovered buried in archived data the detection of phosphate in the water of the moon Enceladus, nearly 6 years after NASA's Cassini spacecraft probe crashed into Saturn and ended its historic mission. This vital component has never before been found in an ocean outside of Earth. One of the 145 known moons of Saturn, Enceladus, has attracted the attention of both astronomers and astrobiologists because of its intriguing geological activity and the possibility of extraterrestrial life. Enceladus, named for a giant from Greek mythology, is a small celestial body with a diameter of around 310 miles, making it roughly 1/7 the size of the moon. Despite its diminutive stature, Enceladus has a major impact on its neighborhood, primarily via influencing Saturn's E ring, the second outermost ring of the planet. Because its surface is primarily covered in new pure ice, Enceladus is one of the solar system's most reflective bodies. Nearly all of the sunlight that reaches it is reflected. Enceladus is one of the sun's brightest objects because a huge portion of its surface is made of water ice. The topography is a mix of smooth, youthful terrain and older, highly cratered sections. The tiger stripe.
And when they say it's made of water ice or it's made of water, I have to ask the question though, are we thinking it's the same makeup? Is it the same type of water that we're accustomed to? The water we get in when we go to the beach? You know what I'm saying? The water we fly over. Are we speaking the same type of makeup? The components are the same. Elements are the same. I be often wondering that. I've never really heard anyone break that down. Are we saying the same thing, or are they saying it's water, but it could be, water that contains this or water that contains that you shouldn't drink. You shouldn't even submerge your body in. You shouldn't do this. You know what I mean? So when I hear them speak about that, that's been a question I've been having, and I haven't heard anybody really answer lately.
Or sulci, four roughly parallel deep blue fissures that spew out water-rich plumes in the south polar area of the moon, are particularly fascinating. The tiger stripes in the south polar area of Enceladus are noted for their active geysers that erupt from them. These eruptions are a type of cryovolcanism, where the eruptions are composed of water, ice, and gases such as ammonia and carbon dioxide rather than molten rock. The material that the plumes expel fuels Saturn's E ring. The evidence for a subterranean ocean of liquid water on Enceladus is maybe the most exciting finding yet. The presence of salt in the plumes suggests that the moon's rocky mantle is in contact with the water, which opens the possibility of chemical reactions that could support life. The ocean is thought to be universal and is encased in an ice shell that might be up to several kilometers thick. Enceladus has emerged as a possible home for extraterrestrial life as a result of the identification of a subsurface ocean, as well as the presence of different salts in organic molecules. Another promising sign for life is the finding of silica nanoparticles, which raises the possibility that there may be hydrothermal activity on Enceladus's bottom. The recent discovery of phosphorus, as phosphates, another essential component of life, in plume samples, has added increased gasoline to the chance of finding extraterrestrial life. Multiple space missions have investigated Enceladus. Although the two Voyager spacecraft passed by it in the 1980s, the most in-depth observations of Enceladus were made by NASA's Cassini probe after it arrived at Saturn in 2004. Cassini found the subterranean ocean and geysers on the moon. From 2004 until 2017, the Cassini spacecraft investigated Saturn, its rings, and moons. In approximately...
Then why is it never talked about? You hardly ever hear about it. The mission or anything to that matter. I don't hear hardly anything. We more so talk about the Voyagers. We more so talk about, James Webb, but that's a given because it's one of the newest. So we more so, the Hubble, we never hear about this.
13 years, samples of ice particles and water vapor emitted by cryovolcanic plumes erupted from cracks on the frigid Enceladus were collected by Cassini's Cosmic Dust Analyzer. The frozen waters of Saturn's moon, Enceladus, have the building blocks for life. But does it have life? The rarest of the 6 elements that make up life as we know it, phosphorus, has been discovered in our solar system's tiniest ocean-containing moon for the first time. Dr. Christopher Glein of the Southwest Scientific Institute is part of an international scientific team that has discovered important evidence that suggests the existence of the key component of life beneath the icy surface of Saturn's moon Enceladus. The discovery owes a great deal to data gathered from NASA's Cassini spacecraft. Phosphates, which contain phosphorus, have been discovered by researchers in the deep ocean of Enceladus. Phosphorus is an essential building element for life. Enceladus is an icy moon with a vast ocean of liquid water hidden beneath its icy surface. Researchers have already discovered other essential components of life, such as carbon, hydrogen, nitrogen, sulfur, and oxygen, in the water of the moon. However, phosphorus, which collaborates with sugars to make a skeleton for DNA molecules and also aids in cell membrane repair and maintenance, had evaded detection up until this point. Now, Mars is almost old news in the search for life beyond Earth. Enceladus, the chilly moon of Saturn, was once disregarded by astronomers who believed Europa, one of Jupiter's moons, was too warm for life to have developed there. Several recent scientific findings, including possible chemical biosignatures, have shifted the focus of scientists toward the likelihood that such extraterrestrial bodies actually do host microorganisms. There are already intriguing hints that simple life forms may have developed on other solar system planets and possibly moons. But as is the case in the majority of scientific subjects, occasionally, progress is followed by setbacks. For instance, studies that challenge earlier research's results that phosphine gas in Venus's clouds might be a sign of life have been published in response. Together, the studies show that the search for extraterrestrial life in our solar system has expanded beyond the initial hypothesis that it might be discovered on planets like Mars or Venus. Scientists are also looking for life on exoplanets around distant stars, as well as radio signals that may be from distant civilizations. A report about Enceladus is one of several recent scientific articles that discuss the hunt for traces of life in our solar system. The Cassini spacecraft sampled the water plumes emitted from Enceladus between 2005 and 2015, and the results were published in the journal Nature Astronomy. Methane and hydrogen were both detected at very high amounts by the probe, lending credence to the theory that bacteria have adapted to life near hydrothermal vents on the ocean floor. It is hypothesized that the ocean on Enceladus is 15 miles deep and is covered by an icy crust as thick as 20 miles. It is believed by scientists to be heated by the tectonic movement of the moon's core rocks in Saturn's powerful gravitational field, and to discharge water from the ocean through fissures in the crust caused by the same tidal forces. He suggested that chemical processes alone may account for the methane found in the sea. While the possibility of life evolving near hydrothermal vents is hotly debated, the study found that it was very likely that it was created by microorganisms, microbes that live in hydrothermal vents or black smokers on Earth's ocean floor thrive off of the chemicals released by the vents. Tube worms, shellfish, and crabs rely on them as the foundation of a food chain that keeps their entire deep-sea ecosystem afloat without the presence of sunlight needed by photosynthesizing plants. However, it is unclear whether life originated in these dark depths or on the planet's bright surface. Phosphine on Venus is still a hot topic of discussion as scientists search for extrasolar life. The detection of phosphine gas led scientists to speculate that bacteria living in the sulfuric acid clouds near the planet's surface were responsible for its production. Researchers have since argued that the original team may not have detected phosphine, that the gas is actually the product of volcanic activity, or that there simply isn't enough water in the clouds to support life as we know it. Professor of astronomy at Cornell University and co-author of the paper suggesting the phosphine could be created by volcanoes, Jonathan Looning stated that only future space probes, like the 2 missions NASA announced last month, could address the issues concerning life on Venus. Looning has also contributed to NASA's Europa Clipper mission, where she worked on the MESI instrument that will investigate infrared light reflected from Jupiter's moon in the coming years. Although not as well understood as Enceladus, Europa may also harbor an ocean of liquid water beneath her icy surface.
Now, a lot of y'all may be wondering, or might have said it in the beginning of the video or some point throughout the video, why are we so passionate? Why are we so persistent and consistent as to trying to find life? Well, I can't speak for them, but I would like to know if life wants, because you could tell there's a race to inhabit a lot of these different planets, you know what I mean? Or see which ones are the possibilities to be inhabited, right? And if that's a possibility, you want to know, okay, if life was there, was it once there? What happened to it? Why is it no longer there? Is it some of the elements in the atmosphere? Is it the lack of these elements? Is it, what happened before? What could take place? Shoot, even the fact of, okay, are we trespassing on somebody else's territory? You know what I mean? Is there life there? What if we get there and we decide to plant our flag and it's something there and then we start a whole war in space? You know what I mean? So it's a lot of different things to think of, but mainly if there was life, why is there life no more?
One of the most plausible places in the solar system for extraterrestrial life to have evolved, it is believed to be older, larger, and probably warmer than the ocean on Enceladus. The unexpected discovery of liquid water beneath Enceladus's ice exterior was made possible by Cassini's exhaustive study. The spacecraft studied samples of plumes emitted from the moon's icy surface, which contained ice grains and gases. The study of the data showed that salt-rich ice grains contained sodium phosphates, indicating that phosphates are abundant in the lunar subsurface ocean. Enceladus, the small moon only a few hundred miles in diameter, appears to feature a soda ocean due to its carbonated, frothy, salty water. If you drank a glass, you might get a soapy aftertaste. Frozen particles travel through crevices in the ice and spurt into space, revealing the ocean beneath. Some scientists have expressed distaste for the name geysers, which has been applied to the plumes because it implies continuous liquid water eruptions like those at Old Faithful. Phosphorus was detected after years of analyzing data from Cassini's instrument hits as it sped past the icy moon. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, schnapps, are the sextet of elements that, combined with water and energy, form the basis of biochemistry on Earth. Phosphorus represents the P in this acronym. Phosphorus has been called a bottleneck for life due to its scarcity. The ocean of Enceladus, however, is rich in it. This means there is no choke point in the soda ocean. Phosphorus, the report states, is thus extremely unlikely to be a limiting factor in the survival of putative life on Enceladus. The icy moons of Jupiter and Saturn are able to support ocean life despite their extreme distance from the Sun because they generate heat through gravitational energy. Internal heat is generated as the small bodies are pushed and stretched by tidal forces created by their orbits around the large planets. The rocky, volcano-covered moon of Jupiter, Io, is a prime example of this occurrence. Hydrothermal vents, like those on Earth that release nutrient-rich water into the ocean, may be powered by tidal heating on Enceladus. Because biology is still in its infancy, even the most fundamental notion of life eludes scientists. Although scientists may confidently state what conditions are necessary for life on Earth, no one knows if these are universally true. Phosphates, which include phosphorus.
That's what I'm saying. No one knows that. No one knows.
Are essential for the development of all known forms of life. Phosphates are necessary for the construction of nucleic acids, DNA and RNA, cell membranes, molecules that transport energy, the skeletal systems of humans and other animals, and the microbiome of plankton in the ocean. Researchers explain the high levels of phosphates found in Enceladus's ocean. Researchers discovered that the plume-forming ocean waters on the moon included phosphate concentrations at least 100 times higher than those found in Earth's oceans. It's one thing to use a model to anticipate the existence of phosphate, but it's a whole other ballgame to actually locate the evidence for phosphate. This is a remarkable achievement in the field of astrobiology and represents a significant development in the hunt for extraterrestrial life. The oceans of several worlds are covered by glaciers. Over the past 25 years, scientists have recognized the solar system's abundance of worlds that protect oceans beneath an icy crust. Pluto and the icy moons of the large planets, such as Titan and Saturn's moon Enceladus, are examples of such objects. These ice-covered ocean worlds can live at a broader range of distances from the Sun than Earth can sustain surface liquid water, thereby expanding the number of habitable worlds in the galaxy. They also made hints that phosphate levels would be higher in cold worlds. In Enceladus, and perhaps other frozen ocean worlds beyond Jupiter, geochemical tests and modeling show that such high phosphate concentrations originate from improved phosphate mineral solubility. The ocean of Enceladus has been found to meet what is often regarded as the most stringent condition for life. The next logical step is to revisit Enceladus to confirm whether or not the livable ocean is populated. This remarkable finding can be attributed to the Cassini expedition, which exemplifies the value of sustained efforts to explore the cosmos. Through the use of the cosmic dust analyzer, sodium phosphates within salt-rich ice grains were identified by Cassini. This high-tech sensor played a crucial role in demonstrating the likelihood that phosphates, a form of phosphorus, are abundant in Enceladus's oceans. It's a remarkable illustration of how technology created by humans has increased our access to and knowledge of the cosmos. The way we see potentially habitable planets may change as a result of this new information. This study adds to the growing body of evidence that frozen worlds harboring underground oceans are far more abundant in the cosmos than was previously believed. This is due to the fact that ocean worlds, unlike Earth, are possible at a broader range of distances from their host stars, increasing the likelihood that they exist. All forms of life on Earth are built from the same basic materials. It's not created from radioactive materials like uranium.
But that doesn't mean it'll be the same somewhere else. And I think it's important to keep reiterating that. Just because the basic forms of life here and how they're formed are like this, doesn't mean where we're going it's going to be the same. You know what I mean? And I hope they keep that in mind when they're looking. And the same things that we need to be able to survive on this planet, another life form their makeup may be different, and they need some of those gases or different things that we find on these planets to survive.
Phosphorus, being only one of 6 required elements, has an especially large impact on Earth's biology. It's essential, for instance, to cellular energy transfer and DNA-RNA structure. Is phosphorus strictly necessary in biochemistry, or may there be an alternative biology? According to scientific theory, phosphorus is the best candidate for the functions it plays in everyday life because it possesses the ideal combination of qualities. The inner ocean of Enceladus is so similar to that of Earth that we would certainly recognize any form of life there. A planetary geochemist at Arizona State University, Mikhail Zolotov, authored a viewpoint essay for Nature and reviewed the new work. He reaffirmed his belief that Mars is where extraterrestrial life is most likely to exist. However, he clarified that he is a scientist, not a science fiction author, and that there are many unanswered questions. We don't know the specifics of what led to the first signs of life, he stated. One of Jupiter's large moons, Europa, may also contain the entire set of Knopp's elements. A Jupiter orbiter being built by NASA called Europa Clipper will get a closer look. The most fascinating planet in our solar system right now, aside from the one we are on, is probably Enceladus. In fact, these amazing discoveries have only increased our desire and motivation for more research, advancing our quest to comprehend the cosmos and our place within it. There has never been a more promising time to study astrobiology.